Okay, thank you. Thank you. Okay. Can you see my diapo?
Yeah, I can see you, but you need to make it full screen, so it will be.
Okay, okay, I will. Okay.
All right, perfect.
Like this.
Yep.
Okay. First of all, I would like to thank you for giving me the opportunity for this conference to participate as a speaker in the theme of treatment of graphene in non-commutative geometry, presented by Dr. Sheikh Mukhtar Fail and Mustafa Mobni from Biskra University. Our subject talking about the study of the 2+1 dimensional massless direct equation under the influence of an external magnetic field in the area of the non-commutative space or the geometry, where we have obtained the energy eigenvalue and the corresponding wave function by using direct method in order to obtain these values of our system. And at the end, we are going to conclude that the effect of the non-commutative geometry has been influenced on this studied system. Moving on to our introduction, which gives some details about the non-commutative geometry and some about the graphene or our material that we have to deal with it in this geometry. So the non-commutative space theory has been widely studied over the past few years, such as the M theory, complication, and string theory on non-trivial context and the quantum Hall effect are related to the non-commutative field theory. Also, that we can see that the graphene or the graphite can be thought as composed by stacking one atom-thick layers of carbon called graphene, that the physics of graphene has attracted attention from a theoretical scientific community since experiment observation revealed the existence of electrical charge carriers that behave as massless direct for the particle. So that we are going to study this material theoretically in the non-commutative geometry. Well, as here we are going to talk about the graphene in non-commutative space. By the way, we are going to give some non-commutative relationship that deals in this geometry. First of all, we are going to where the coordinates operator satisfy the commutation in the first equation. Here, theta is the anti-symmetric tensor of the space dimension. Then we are going to talk about the product of any two function in this geometry by using the Samuel product. Also, we are here given some details about. Sorry, it's gone. I think.
No, it's still to your screen.
Okay, okay. Can you see it right now?
Yeah, it's still to
Okay.
your screen. Can continue.
Okay, so that in equation 3 we are given the coordinates of this geometry. Moving on to the next. Just a minute, because I have trouble.
Hello, Mr. Lahder. I think it's technical problem. Did you hear us? Can you hear me, Mr. Lahder? Well, the profile decision, I think we need to wait in several minutes for Mr. Lahder to come back to the room. Hello, Mr. Lahder. All right. So it's really technical issues, specifically on the internet. So maybe we will wait in maybe 1 minute. If he doesn't come back, so we will move to the next presenter. Hello, Mr. Lahda. Are you with us? Hello? All right, maybe we can move to the next presenter since Mr. Lahda have a technical issues. The committee, could you provide the slide so we can move to the next presenter? So we will put Mr. Lahda in the next one. The committee, are you there? All right. Okay. So we will move to the next speakers. Well, maybe Mr. Lahder, we will put in the next presenters. We have another invited speakers from. Okay. Okay. Thank you, the committee. We have another invited speaker from Universitas Sumatera Utara and Universitas Negeri Malang, Indonesia. She is Abdul Floranda, Doli Bonardo, Ida Fairuza Alabadiah, Mahapusan Sitomarang, and Karista Charijan under the paper topic Design Construction of High Voltage Electrospinning with Flyback-Based Power Supply for Nanofibers Manufacturing Application. So I see that Mr. Bonardo.
Sir,
oh,
sir,
okay.
please.
Yep.
Excuse me, please.
Okay. Okay. Could you present again?
Sir,
Yep.
please.
Yep. Yeah. We can
I'm
hear you.
Lakhdar. Yes, I have. I will share it. Okay.
Okay.
I have figured it out. Yeah.
Yep. Yep.
Okay.
Okay. Sorry, Mr. Bernardo. We will continue
Okay.
Mr. Lahdar's section. Okay.
Okay. So we are given. We are normally in this slide for the graphene in non-commutative geometry. First of all, we are given the coordinate operator to satisfy the first equation here, that which given theta is the anti-symmetric tensor of the space dimension. In the context of this deformation, the product of two function is equivalent to the Sturm-Liouville product, which is given in the second equation there. Also, we are defining the x for the position and for the momentum tensors here for the third equation that is not the same as the in the ordinary space that we have dealt in the easy way. So that we're given the parameter symmetric which is chosen by for the z-axis. Right now we're given for let's us first recall the fundamental of the graphene physics on non-commutative geometry approach. Here we follow the steps described in the reference for 14, for example. The basic equation in the theory of direct equation for the free massless particle given in the fifth equation there. P here is the momentum, and psi is the function, wave function that we are given deal with, and the E is the energy. We are given. We are going to search it about a direct method. Okay. By using the massless direct equation there, after using the equation 3 into 5, by using, for example, the non-commutative geometry, the system becomes in the sixth equation where P minus here, P minus given by P minus E for 2, where the B is the intensity of the magnetic field. And for the VF, which defined as the Fermi velocity, which given in this value. Then we are going to calculate the scalar product there of P minus scalar P minus. After calculate it, then we are going to the second term, which is the vector product, which P minus vector P minus, and we are given to where we are going to organize this equation there after straightforward calculation of the sixth equation by using, and then we are going to use the polar coordinates. We have also to give some appropriate transformation until we get the equation number 7, which is similar to the confluent hypergeometric function, which we have given this condition for the NR for the n has this form in the equation number 8. Let's there after using the confluent hypergeometric function, and it's a simple way to give the energy spectrum as in the equation 9. Here we note that the LB it's they call it the magnetic length, which given in this form as we can see it, and the wave function of this of our system given in this in the equation number 10 by using the confluent hypergeometric function, where C is normalization constant magnetic field. By the way, we can test our obtained results by using, for example, here for theta equal to 0, we obtain the ordinary study of graphene in commutative space, not in non-commutative space. We are going to conclude our subject here. In this work, we have studied the 2+1 massless Dirac equation under the influence of an external magnetic field in non-commutative geometry, where we have obtained the energy eigenvalues and the corresponding wave function by using a direct method. Also, we can notice that our system has been affected by the non-commutative geometry. Thank you.
Thank you, Mr. Lahdar, for your nice presentation. I think we learned a lot about your paper through the graphene with the non-commutative geometry as a way to see the graphene itself. And ladies and gentlemen, this is Q&A session, but since we have a limited time, so I think maybe one or two questions, please. If you have a question to Mr. Lahdar, you could use the chat box and also raise your virtual hand. Okay, while waiting from the participant question, Mr. Lahdar, maybe I have one question for you, Mr. Lahdar. Previously, you maybe you don't mention why you use this non-commutative geometry to see the treatment of graphene, and the second question is about is there any factors that could be improved through your paper? Please, Mr. Lahdar. Am I clear?
Yes, 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 I can hear you. Okay.
Okay. Please.
The non-commutative geometry, it's a geometry that we can deal in spaces that we are going to introduce this geometry in relativistic equations, for example, or non-relativistic equation, which give with differential operator such as the momentum and the position. It's not the same as an ordinary case.
All right, so it's related with momentum and position. So what?
Yes, there are. Excuse me. There are other articles, for example, talking about this geometry, such as Mirza. Mirza, it's an Iranian author that dealt with Klein, Gordon, and Dirac, also Dikapi in non-commutative geometry. Yeah.
All right. So what the aspect that could still be improved from your paper, Mr. Lahdar?
The improve that we can show that, for example, for the results such as the spectrum energy and the wave function are not the same as in ordinary case, for example, or the commutative space, and the non-commutative space is not the same. And there are impacts, for example, for the non-commutativity for the position, it's this or the theta here, it's the antisymmetric tensor. It's not the same as in the ordinary case.
Oh, I see. Yeah.
Okay.
Thank you, Mr. Lahdar, for your answer. I think it's
okay. Thank you too for understanding our trouble. Thank you very much.
Yeah.
Thank you.
And also congratulations for being one of the invited speakers for this ICAMT.
Thank you for this opportunity. I appreciate it. Thank you very much. I'm pleasure.
All right. So, ladies and gentlemen, maybe we would move to the next speakers. It will be Mr. Dolly Bonardo. He will tell us about the design and construction of high voltage electrospinning with Halibut-based power supply for nanofibers manufacturing application. And I think Mr. Bonardo already here. And for Mr. Bonardo, time is yours. You have 25 minutes to deliver your paper presentation. Please.
Okay, thank you. Can you hear my voice?
Yeah, it's clear.
Okay, let me introduce, sorry, and let me share my presentation.
Sure.
Okay. Can you see my full screen?
Yeah, we
Okay.
can see. Okay, perfect.
Okay. Okay. Thank you for the opportunity given to me to share to presentation about our research with the title of Design and Construction of High Voltage Electro Spinning with flyback based power supply for nanofibers manufacturing applications. This research was carried out by Ignoranda, me, Doli Bonardo, Ida Paul Ruja Albadia, Marcosan Sumarang, and Krista Tarigan. We are from Department of Physics, Faculty of Mathematics and Sumatera Utara, Citingnya, and one of us is from Department of Physics, Faculty of Mathematics and Natural Science, Universitas Negeri Malang, in Malang City, Indonesia. Okay, as we know that the rapid development of technology, especially nanotechnology. Sorry, wait a second. I will give the pointer. Okay. As you know that the rapid development of nanotechnology in the last few decades has had an impact on the development of various industry, including the nanofibers industry. Especially, I think the nanofibers is uh, the member of the textile material. So the application of nanotechnology in the textile industry can produce the functional product. Nanofibers in the textile are defined as the fibers with a diameter of 100 to 500 nanometers. And nanofiber also has a superior properties such as high surface area, porous structure, and modulus of elasticity. Uh, Nanofibers are reported to be effective in medical applications, uh, and then for filtration material or membrane material, and for protective fabric or for energy storage. Basically, the manufacture of nanofibers can be done by several methods, such as uh, actually divided by two different methods. First is chemical synthetic method, including chemical vapor deposition, hydrothermal, sol gel, implant assisted synthesis, and electrochemical deposition. And for the next method is the physical scientific routes, including mechanical milling, physical vapor deposition, laser ablation, and one of them is electron spinning. The electrospinning method is the simplest technique compared to the other two methods and is capable of producing nanofiber materials up to the submicron scale or to nanoscale. Uh, Electrospinning also has the advantage because it can make the efficient nanofiber by utilizing the influence of an electric to produce jets of electrically charged polymer solution or malts. Electrospinning also can produce the nanofiber from all kind of polymer. And we have to know that electrospinning also can scaling and control the morphology. The electrospinning utility or the electrospinning tools in when it uses to produce the nanofiber need the high voltage power supply, and we have to know that the flyback method in the circuit strategy can become uh, the rule strategy of the high voltage power supply. Okay, the next is methodology. In this study, we use the polymer solution of polyvinyl alcohol or PPA. So 5 grams of PPA was mixed into distilled water and stirred using a magnetic stirrer at the temperature of 90 degrees of Celsius for 4 hours. And then dilute to a volume of 100 milliliter. So the solution was allowed to cool to room temperature. Okay, actually we have to say that the high voltage electrospinning in this study mean that it produces a high output voltage even though it is powered by a low voltage. The flyback based power supply will be the resulting output voltage amplifier. This high voltage electrospinning is made using the Atmega 328 microcontroller for autonomous systems. An LCD with size 16 times 2 is used as the display, and the microcontroller can provide data directly to the LCD, which is equipped with a driver to convert the ASCII output data of the microcontroller into a character display. Notification with sound as a marked system when the stepper motor is on or off is executed using an Arduino Uno based buzzer circuit. Then a series of push buttons are used as input for the board system to run electrospinning, where each button has a different code function. Really. The microcontroller cannot directly control the stepper motor. So this driver serves to rotate the stepper motor clockwise or counterclockwise. By giving a high signal alternately to the input of the stepper motor driver circuit, the movement of the stepper motor can be controlled by the microcontroller. This is the high voltage electro spinning circuit, and in the right picture is the real picture of electro spinning. Okay, we are going to result and discussion. First, we measure the output voltage of the high electro spinning when it's powered by several input voltages. From the data, it can be confirmed that the power supply using the flyback method is able to amplify the input voltage up to an average of 900 times. So this high voltage produces an electromagnetic field that will spray the fiber form of the polymer solution. So this high voltage produces a high electric field that helps produce fiber at large bending frequency, indicating that the flyback method can be a high voltage power supply for nanofiber electrospinning. Next is the graph of the relationship between the input voltage and output voltage generated by a flyback-based power supply. This increased voltage, as you see, this increased voltage is because the purpose of flyback transformer is to take pulsating direct current and convert this pulse into thousands of volt output. From the graph, it can be seen that the increase in the output voltage occurs along with the increase in the given input voltage. And next, the picture, sorry, okay. The picture is shows the stability of the output voltage produced by a flyback-based power supply when run for a certain period of time. The input voltage of 10 volts produce a fluctuating output voltage. As you see, there are fluctuation value in the output voltage. The difference in the value of the output voltage at a certain time is not too wide, just in the decimal kilovolt. Meanwhile, the stability of the flyback-based power supply voltage when given an input voltage of 20 to 30 volt is relatively normal. So this indicating very small and very narrow fluctuation in the value of the resulting output voltage. So we can conclude this high across the high voltage electrospanning is quite stable. And next, in this study, PPN nanofibers films were prepared using a high voltage electrospanning which were designed and constructed where the input voltage were 15, 20, and 25 volts for 3 minutes running to find out how difference in input voltage could affect the continuity, distribution, and size of the PPA nanofibers produced. In the screen, you can see the SIM, scanning electron microscope picture. In the left is the PPA nanofiber that conducted by 15 volt of input high voltage electrospanning. And the right with the different magnification, you can see the size. The continuity and the distribution of the BPA nanofibers are less dense and have swelling at the fiber junction nodes. This is the swelling at the fiber junction nodes. The fiber density is influenced by the voltage pulse on the PPA which is created on the substrate. The average distance between the fiber ropes is 0.99 micrometers, and for the fiber diameter is 0.179 micrometer or 179 nanometers. And the next is the second sample that produced by 24 input voltage of the electrospin. The electrospun PPN nanofibers distance between the fibers decreased significantly. You can see less of uh, porosity. and the phenomenon of the fiber compaction occurs. And also, the PVA nanofiber junction node also strained so that the fiber size is reduced to 146 nanometers. And the last sample, the electrospun PVA nanofiber when powered by an input voltage of 25 volts has a relatively good density as well, but it is more tenuous when compared to a voltage of 20 volts. In addition, fiber swelling also occurs. You can see the fiber swelling. All of fiber occurring swelling. It indicates the occurrence of due to the increase in the viscosity of the PVA solution at high voltage. And the last is the mechanism. In principle, the mechanism began by fishing a polymer solution that is given a high voltage powered by flyback based power supply using a spring pump to form droplets of solution at the tip of the spinneret capillary. So the flow rate of the polymer solution is estimated to be too fast to exit the spinneret hull, causing a push against the tail cone of the PVA solution, and finally falling dripping, where this even occurs repeatedly until nanofiber form. In summary, actually, we have to say that this work has succeeded in designing and constructing electrospinning with a flyback as the power supply with a high output voltage of 12.57 to 22.68 kilovolts, and the horizontal system in which the collector is at the front and is covered by an aluminum coil so that the jet of polymer solution moves forward toward the collector is the design chosen to optimize the principle of the telecom pump at the tip of the string. And the electrospinning tool have been obtained from 3 voltage variation of the 15, 20, and 25 volts and produce nanofiber with 130 to 119 nanometers in size range. And the last, the flow rate of the polymer solution was rather difficult to control to the gravity flow of the polymer solution. So maybe in the next research can make the electrospinning with the design of with the vertical orientation. So those for the exploration to optimize the polymer flow rate during electrospinning need to be carried out in the picture. Okay, maybe just that what I can deliver to you. Thank you all. Thank you for the chance. Thank you for close attention. Thank you.
Thank you very much, Mr. Bonando, for your insightful presentation. I think it's also enlightenment through the nanofibers. You provide with flyback based power and you could produce some of nanofibers, if I'm not mistaken. And it's intriguing, I think, because you have input voltage in 900 times. I think it's a huge number, and also high output voltage in almost almost 13 to 23 kilovolts. And ladies and gentlemen, if you have a question for Mr. Bonardo, please feel free to ask directly, or even you could use the chat box. But as usual, while waiting the participant, maybe I will start with my question, Mr. Bonardo. Basically, I'm really interested because it's related with nanofibers, and you also mentioned about several methods that is really interesting for me. And one of your data that you mentioned that you gave the average distance between the fiber ropes formed is almost 1 micrometers, and diameter is almost 180 nanometers. In your opinion, Mr. Bunardo, is it already optimum yield, or it still could be improved, or anything that could be added to make it more perfect?
Thank you for your question. Actually, I will get the question. Okay. Actually, the size of PPA nanofiber produced by the high voltage collector spinning with design and constructed by our research is optimal just for the compare sample between the last reference. 130 to 190 nanometers actually include to the submicron scale, not nanometers. But in the last reference, it can be optimal size range conducted by electron spinning to produce the with distributed nanofibers. Maybe just that what the answer.
I see. Okay, thank you, Mr. Bunardo, for your information. And I think the gravity flow is also a big deal for this method, I think. And I hope you could improve it more, and we can maybe have another invention in the future. Thank you very much, Mr. Bunardo. Since we have a limited time, ladies and gentlemen, so I don't find any new in our floor, specifically in questions. So we will move to the next session, and once again, congratulations to Mr. Bunardo for being one of the invited speakers in the ICAMT 2021. And we will move to the next speakers. It's oral session or contributor. Sorry, it's come from National Research and Innovation Agency or Green Indonesia with the topics uranium separation from Bangka monetized by solvent extraction method using G-octyl amine or TOA. We have Miss Krishna here. Ms. Krishna, the time is yours. You have 15 minutes to deliver your speech. Please.
Okay. Thank you, Mr. Wahyu, for the opportunity. Is my voice clearly?
Yes, we can hear it clearly.
Allow me to share my screen. Good afternoon, ladies and gentlemen. I'm glad to see you all. Let me introduce myself. My name is Krishna Prasanti. I am from Center for Nuclear Minerals Technology and Research, Nuclear Power Research Organization, National Research and Innovation Agency. On the occasion of this afternoon, I will deliver my presentation entitled Uranium Separation from Bangka monazite by solvent extraction method using trioctyl amine. And this is our team. Bapak Kurnia Trinopiawan, Bapak Aditya Widian Putra, Budi Yuliani, Rahmat Fauzi Hidayat, Erlan Yudita, Romi, and Bapak Kurnia Setiawan Widana. This is the outline of my presentation, starting with introduction, followed by methodology, result and discussion, conclusion, and acknowledgement. Okay, let's start. What is monazite? Monazite is one of the minerals in the tailing from tin mining activities, contain valuable and strategic elements such as rare earth element, phosphate, uranium, thorium, and phosphate. The percentage of each element of monazite are REE 58.97%, uranium 0.298%, thorium 4.147%, and phosphate 23.712%. And the utilization of each element in monazite. Phosphate is used as raw material for fertilizer, while uranium and thorium as for nuclear power fuel for nuclear power plant. And REE is used as advanced material science, including hybrid and electronic automobile, fluorescent light, metal alloy, critically military application, and in the manufacturing of high intensity magnet, electrical assembly, etc. Research at Center for Nuclear Mineral Technology National Nuclear Energy Agency or called PTBGN Batam have succeeded in separating rare earth element as hydroxide compound with 85% recovery through this process. This process starts with comminution. Comminution is process for reducing the size of monazite particle. The monazite particle has to be reduced to give greater surface area, so the reagent would be effectively contacted with the particles. In this comminution process, monazite was ground to a size of minus 325 mass. And the next stage is alkaline leaching. The alkaline leaching using sodium hydroxide to dissolve phosphate and convert monazite from phosphate compound to hydroxide. Phosphate in aqueous phase separated from the leaching residue by filtration. Phosphate bond in monazite was broken by sodium hydroxide solution in high temperature and resulting soluble form of phosphate, while uranium, thorium, and REE kept in solid phase as hydroxide. The next, solid phase of hydroxide is reacted with hydrochloric acid in certain pH condition and temperature to dissolve REE selectively in the process selective dissolution. The selective dissolution process is aimed to dissolve REE with small amount of uranium and thorium impurities. REE contained in leaching residue was dissolved using hydrochloric acid at certain pH and temperature, and resulting REE chloride solution with small amount of radioactive element impurities. Next stage is multi-stage precipitation. Solution obtained from selective dissolution stage need to be purified, especially to reduce or remove radioactive element prior to precipitation of REE product. Based on different precipitation pH between REE and uranium thorium, the multi-stage precipitation would be used. REE would be precipitated at higher pH than uranium thorium. All radioactive elements were precipitated when pH of REE chloride solution increased to neutral pH, and REE hydroxide product would be obtained by continuing the precipitation process into pH 8 to 9. By this multi-stage precipitation process, 85 REE is recovered from monazite and uranium thorium content in REE hydroxide product less than 50 ppm. From these processes, uranium and thorium are mostly concentrated in the residue of selective dissolution and had not been separated. To support energy independence, there is currently a plan to build commercial nuclear power plant in Indonesia. The fuel for nuclear power plant is uranium oxide, which can be obtained from the yellow cake. In attempt to produce yellow cake, the uranium will be separated from monazite. In this research, uranium is separated from thorium, RE, and other impurities by using solvent extraction method. Solvent extraction method is a process of separating a component from a mixture based on a distribution process of two immiscible solvents, namely aqueous phase and organic phase. The separation of uranium from the feed solution, which still contain various elements, is conducted by using selective solvent organic phase for uranium. The organic solvent or extractant used in this research is triethylamine or TOA mixed with kerosene and isodecanol. So the research is focused in this part, precipitated from selective dissolution, dissolved with sulfuric acid as a feed for uranium solvent extraction. Research on separation of uranium from monazite with solvent extraction was conducted through two stages of activities, namely solvent extraction, feed preparation, and solvent extraction process. Solvent extraction feed preparation was carried out by dissolving selective dissolution precipitate with sulfuric acid, and while the solvent extraction process was carried out by mixing triethylamine, kerosene, and isodecanol with this composition: TOA 5%, kerosene 93%, and isodecanol 2%. With the parameters studied are ratio of organic aqueous, pH, temperature, and extraction time. The process of the research, solvent extraction feed and extractant was put into a beaker glass and then stirred with a magnetic stir. This process. Magnetic stir at various time, varied organic per aqueous, various time, and various temperature. Aqueous or raffinate obtained was analyzed for the level of uranium, thorium, RE, and impurities such as calcium, iron, and magnesium using UV spectrophotometer and ICP-OES. The result for O/A ratio parameter. This figure, it can be seen that the greater ratio of O/A, the extracted uranium also increase. If the ratio 1/3 until 2/1, the extracted uranium increased but not significantly, which was in the ring 68 until to 75%. And after O/A 3/1 and to 4/1, there was quite significant increase of extracted uranium until 90%. Furthermore, at upper A ratio 5/1 to 6/1, recovery of extracted uranium tend to remain in the range of 91%. Upper A ratio directly affected the extraction process because the capacity of extractant increased with the increase in extractant volume. The more organic solution or extractant solution used, the more uranium was extracted into organic phase. This was due to the presence of more organic phase to the more uranium that bounded to the organic phase would also increase. As the thorium, the extracted recovery at variation of upper A ratio tend to remain in 67 and to 71%. From this data, the optimum upper A ratio chosen was at ratio 4/1, with the recovery of uranium and thorium 90.80% and 68.80% respectively. Next, the pH parameter. From this figure, it can be seen that the higher the pH, the higher the extracted uranium, and it reaches 99.95% recovery at the pH of 2.5. As for the thorium, the opposite happened, which was the higher of pH, the lower the extracted thorium. From this data, the optimum pH was chosen at 1.5, which have fairly high uranium recovery of 99.90% and relatively low thorium recovery compared with others, which was 63.93%. And the temperature parameter, from this figure, it can be seen that the increase of temperature did not have a significant effect on the recovery of uranium and thorium. For the extraction of uranium with the process conducted at temperature of 30 degrees Celsius, the recovery already reached 99.90%, and then to be stable at that number even when the temperature was raised until 70 degrees Celsius. Likewise, the recovery of thorium tend to remain in the range of 63 until 65 at the temperature variation. From this data, the optimum temperature chosen was 30 degrees Celsius with uranium and thorium recovery 99.90% and 63.93% respectively. And the last extraction parameter type. From this figure, it can be seen that at 2 minutes of extraction time, the recovery of uranium had already reached 99.87%, and with increasing extraction time up to 20 minutes, the recovery tends to remain in that range. Similarly, the recovery of thorium was in the range of 63.0 29 until 67 at a variation time to 2 to 20 minutes. From this data, the extraction time, optimum time extraction time was chosen at 2 minutes with the uranium and thorium recovery of 99.87 and 63.09% respectively. The conclusion from the result of the study obtained, the optimum extraction condition is over a ratio of 4.1, pH of 1.5, temperature of 30 degrees of Celsius, and extraction time of 2 minutes with uranium recovery of 99.87 and recovery of thorium 63.03%, and while REE and other metal impurities are not extracted in the organic solution. The authors would like to thanks to Center for Nuclear Mineral Technology, National Nuclear Energy Agency, and LPDP for funding this research, to Afik Aswar Pratama and Yoga Permana for doing the analysis using ICPOES and UV spectrophotometry, and also to PT Timah for providing monazite as raw material used for this research. Okay, thank you so much for your attention. Time I give back for the moderator.
Thank you. Thank you, Ms. Risna, for your insightful presentation. I think it's also really important because it's related with our mineral resources, and you mentioned about the Bangka monazite to be split to uranium and also thorium, and promisingly, you have almost 100% of the yield of your process. I think it's really promising. And ladies and gentlemen, since we have a limited time, maybe we only could provide one question, and anyone? Okay, if there is not, so it will belong to me. Ms. Risna, thank you for your presentation, and I just curious with your research. I think it's really important because one of the main problem of Indonesia is we are abundant with the mineral resources, but we still lack of the technology, specifically in mineral processing. So I think your research will a bridge to this one of the goal for Indonesia. And when we speak about a bigger scale of your processing, is there any factors that will be affect the impurity of the result during with your method? When we talk, maybe you will apply for pilot scale or maybe bigger than that. Is there any challenge that will be on the road when we talk about the pilot project in this uranium exploration project?
Okay, thank you, Mr. Wahyu. I try to answer your question. To upscale to the pilot scale.
Process.
Of course, there's maybe little or much problem because the process in the laboratory different with in the pilot. We have pilot plan in our PTBGN, a pilot plan for processing this process for processing monazite to REE hydroxide and to uranium separation by solvent extraction. The process in pilot scale already still doing in this year, and honestly the result a little different with the result I report in this conference. in this report, I report recovery until 99%, but in pilot scale, the recovery under 99%, still in 70%. Yeah, maybe the scale of material affect the process and problem in the pilot also. That's a problem.
All right.
In pilot with the pump, with the reactor, like that.
Okay, thank you, Ms. Risna, for your answer. I think it's insightful also because we still have a challenge on that. Because when we have a good way to make it more bigger, so I think we have a big bargaining power to international level since we have abundant of the mineral resources. Keep it work, Ms. Risna, and we will wait for your next research, promising research in mineral extraction. And congratulations, Ms. Risna, since you already present your paper here, and it's nice to see you here to learn from you specifically on the mineral resources extraction. And thank you, Ms. Risna. And ladies and gentlemen, actually we still have one speaker, but I just contact him or her, but they withdraw their paper. So Ms. Risna become our last speaker for this this afternoon session in parallel. So that's all from me as a moderator for this session, and hope you enjoy this session and also have many experience and also learning experience through this session. Thank you very much, and I will give this virtual stage back to Ms. Ida. Thank you very much.
Thank you, Mr. Bayu. Big applause for the performance. Thank you. And before closing, all Zoom participants please to open cameras because the photo session will start soon. Okay, I will. Okay, ready. 1, 2, 3. Okay, finished. Thank you. And then remaining participants to fill in the presence link in the column chat Zoom. This event would not be possible without our supportive sponsor, International Union of Material Research Society, Material Research Society Thailand, and PT Surveyor Indonesia. Now we have come to the end in the ceremony. On behalf of the organizing committee, we would like to thank you for spending your time with us this morning. Great appreciation also goes to moderator, speaker, and lecturer and student. We have provided great support and to run this program successfully. Thank you very much, ladies and gentlemen, and please back to main room. Thank you.